Hello, this is Brother Cromer from the Math Department, and this is a continuation of the videos dealing with inference for two means paired data. So first I'll be talking about confidence intervals, and then I'll wrap it up with checking requirements. Okay. So first of all, here is the first confidence interval that we saw in this course. It's a one mean sigma known, where we're dealing with a z-distribution, okay, and we're dealing with the population standard deviation. Okay, we know the population standard deviation, so we're taking a point estimate plus or minus a margin of error to get a confidence interval. Okay, but how realistic is sigma, our population standard deviation? How realistic is that being known? Okay, well, it's not very realistic, so therefore we use what's called a one sample t confidence interval, or a one mean sigma unknown confidence interval. And so now we deal with the t-distribution, but also we have s as well. Okay, we're going to use s, which is our sample standard deviation. We use our sample standard deviation to estimate our population standard deviation. So we get this confidence interval where we also have a point estimate plus or minus a margin of error, which is over here on the right, the plus or minus sign. But instead of doing this by hand or using a calculator, we'll be using Excel or SPSS to calculate the one sample t confidence interval, or the one mean sigma unknown confidence interval. So now today, or for these videos, we'll be covering matched pair confidence interval. Now the confidence interval for a matched pair is d bar, which is the sample mean difference. Basically what that means is that we have a column of differences, and then we take the average of those, or the mean of those differences, to get d bar. That's our point estimate. And then we add and subtract a margin of error, where we take a critical value from the t-distribution, times it by our sample standard deviation of the differences, and that's how it's defined down here, divided by the square root of our sample size, where n is the number of pairs in our sample. So just like with all the other ones, we take a point estimate plus or minus a margin of error to get a confidence interval. And here we'll be also using Excel or SPSS to get our results. So here's an example of SPSS output here on the next slide, okay, where first of all, this is the mean of the differences here. When we take the sample of 13, we get a mean of the differences here and the standard deviation of the differences. We also get degrees of freedom, which is equal to 12. And then we construct a 95% confidence interval. How we interpret this is we say that we're 95% confident that the mean of the differences is between negative 2.06 and 1.44. So the question is, can we detect a difference? Can we tell if there is a difference between father's heights and son's heights based on our sample of 13? Well, the answer is we can't tell, even though it looks like it's tilted towards one way. But since it's possible that we can get a negative difference on average or a positive difference, and 0 is within our confidence interval, we cannot tell if there is a difference. So therefore, 0 is in our confidence interval, so we cannot tell if there is a mean difference in heights between fathers and sons. Okay? So then, the next example here, 27 women participated in a 9-week study, 9-week weight loss study. During the study period, the participants were provided a reduced calorie diet. Their weights were recorded at the beginning of the study and 9 weeks later. The difference of the weights is defined as the post-study weights minus the pre-study weights. The researcher expected that the mean difference in the weights would be negative, in other words, that the women would tend to lose weight. Since you are a crackerjack statistician, you would like to construct a 95% confidence interval on the mean difference between the post-study weight and the pre-study weight. So what I'll do is let me show you this output that I have from SPSS, which you can also see in Excel. Or similar you would find in Excel. And this is where you get your confidence interval for the 95% confidence interval of the difference. Okay? It's negative 8.0585, that's our lower bound, and negative 5.5489 is our upper bound. So how we interpret that is we say that we are 95% confident that the mean difference in weight is between negative 8.059 and negative 5.549. So the question is now is, can we tell if there's a difference between pre-weight and post-weight? Well, the answer is yes. Since 0 is not in our confidence interval, there does not appear to be a mean difference in the post-study versus pre-study weight. So in essence, for a confidence interval with matched pairs or paired sample data, if 0 is in our confidence interval, we cannot detect a difference between the two groups. But if 0 is outside of our confidence interval, then we can detect a difference. Okay. Now, lastly, let's talk about checking requirements. Now, before doing a confidence interval or hypothesis test for matched pair T or a paired sample T test, we have to assume a simple random sample. Sample data are matched pairs. But given some data, which we'll give you throughout this course, if we give you data that's matched paired or paired samples, then we have to find and see if the differences are normally distributed. So we have to use a QQ plot. Or if n is large, if n is greater than 30 or equal to 30, that's a guideline, where n is the number of pairs, and so we apply the central limit there. Okay. So also on top of requirements, we may ask you to do descriptive statistics. For numericals, we'll ask you to calculate a sample mean and a standard deviation of the differences, and the graphical, it's either a histogram or box plot of the differences. Okay. Now checking the requirements. Here's an example. If I go to my output here, here's an example of a QQ plot. Now this here is an example where this is the father-son's height, the differences, and it looks like the differences are approximately normal. They're at or close to the line. And then here's another example of it where here is the difference in pre-weight versus post-weight, and it does look the differences look fairly normally distributed. Here's an example of a box plot as well as a histogram. This is pre and post-weight. And this is an example of a box plot as well as a histogram for the difference in fathers and sons' heights. You can get the mean and standard deviation for the differences from doing, when you look at the output for what you're doing. They usually list the mean and standard deviation, whether it's Excel or SPSS. There is a mean and standard deviation of the differences that are listed. Usually is a table above where you get your test statistic, degrees of freedom, p-value, and your confidence interval. Okay, and that concludes the video dealing with inference for two means paired data. If you have any questions, please talk to your instructor or your TA.